So basically this is the third part of the equation. So this is basically question number 11. So based on your interpretation for the diagrams, that would be, for example, that the box of mass m is actually sliding down the incline or the ramp, and they had a frictional, which is kinetic frictional, that does the work to slow it down a little bit. So you're looking for acceleration, so you don't know what acceleration is, so you're gonna have to apply the free body diagram. You have to have the weight, which is mg. Mg psi theta. This is the angle right here, so that will be mg cosine theta. And that should be your normal force, and that's actually your kinetic frictional force to slow it down. So how many forces do you have total? 1, 2, 3, 4. So basically you actually have 4 different forces acting upon each other. So you're gonna go ahead and use this Newton's law of motion in the y direction, which is perpendicular to the surface. So that will be normal force minus mg cosine is equal to 0 because they're not moving up and down, so there's no movement in the vertical or perpendicular to the plane. So normal force is equal to mg cosine theta n is equal to mg cosine theta. Okay, that's what it is. And now we're going to go ahead and apply sigma x direction, which is parallel to the plane. So how many forces do you have? You have the weight already incorporated with the angle minus Fk is equal to 0. Mg psi minus, okay, and I'm gonna replace what the frictional force is equal to mu n in there. So I will have mu, my n is actually mg cosine theta is equal to 0. Oh, double check. If this is, okay, for example, if there is movement on the plane, would the acceleration be 0? No, because you were asked to calculate what the acceleration is, so you have mass times accelerations. So acceleration, so I'm just gonna do this way. I put everything else, okay, the only thing I have in common here is m, so I put m outside. G psi minus mu G cosine theta, okay? And then I have to divide both sides by m, so my acceleration is equal to G gravity psi minus mu K G cosine. So when you're looking at the answer key, you should be able to notice which one is your answers. So question 12 is pretty easy. Look at the graph. Okay, they ask you at time is equal to 1 second. What is accelerations, right? So when you have velocity versus times graph, the slope is actually as acceleration. So 2, 4. So slope is equal to change in the y times change in the x direction. So the y is actually For the x is actually 2, that would be 2 meter per seconds. Square. Because the slope itself is actually accelerations. So question 13, easy, simple again. You're looking at the force times just impulse. Okay, let's look at what it's actually telling you. So the force times time, so the area under the curve is actually the impulse. But this graph, it doesn't tell you. It tells you to figure out what is the x. So basically, it tells you that a t equal to 3 seconds. 1, 2, 3. The force, you're gonna have to figure out what the force is first. But it said A is equal to 5 meter per second square. So you're looking for the acceleration. So, I'm sorry. You are looking for the mass. So you're looking for the mass. You don't know what the mass is, you know, acceleration. You figure out what the force from the graph. So basically, let's interpret the force. So at t equal to 3 seconds, the force is actually 15. So I have F equal ma. So F equal ma, that's the second Newton law of motions. And we're looking for mass, so my F is equal to 15 and my A is equal to actually 5, so that should be 3 kilograms. And that's how you would figure out what the answer is for that question. Let's talk about that question real fast. So question number 14 is a little bit tricky. So we tell you the free body diagram. So basically you have an mg and you have a normal force and you have frictional force. So this is true if the object travels in the right direction, because you know frictional force is always acts on the opposite of the motion. That's what it is. Opposite of the motions.